This content is provided for educational and informational purposes only. All information presented is intended for professional development and industry awareness. Whilst we endeavor to ensure accuracy, viewers should independently verify all information before implementation. No responsibility is accepted for decisions made based upon this content. Professional consultation is recommended for specific implementations. Hello, everyone, and welcome back to the channel. I'm absolutely excited to share something with you today that could fundamentally change how you think about machine learning deployment costs. Just last week, I was speaking with a senior ML engineer at a Fortune 500 company, and they told me something that honestly shocked me. They said their team was spending over £8,000 monthly on infrastructure that was only being used about 15% of the time. That's when it hit me. This is exactly why I needed to create this comprehensive guide for you. What if I told you that Netflix deployed their recommendation system and saved millions in infrastructure costs using one simple approach, and Tesla reduced their real-time model costs by 90% while improving response times by 25%? The numbers I'm about to share with you come from real production environments, and they're going to challenge everything you think you know about ML infrastructure costs. I've just discovered research showing that 83% of organizations now use machine learning, but here's the concerning part. 53% of projects get abandoned due to infrastructure complexity. In the next 12 minutes, I'll reveal the serverless machine learning strategy that's revolutionizing the industry in 2025 and saving companies thousands every month. And here's the best part. By the end of this video, you'll have a complete roadmap to implement this yourself, potentially saving 90% on your deployment costs starting this month. Traditional infrastructure for machine learning creates significant challenges for engineering teams. Companies face high infrastructure costs from maintaining always-on servers, even when there's little activity, which creates substantial ongoing expenses. There are major scalability challenges where manually adjusting resources to handle changing demand is complex, slow, and often results in either too much or too little capacity. The operational burden of managing servers, updates, and ensuring reliable performance takes valuable engineering time away from actually building better models. And slow deployment cycles with dependencies on traditional IT operations and lengthy setup processes delay getting new capabilities to market. Here's the reality for machine learning engineers and data scientists today. If you're part of the 95% spending your time on infrastructure instead of actual machine learning work, this presentation will change everything. The serverless computing market just exploded from $26.5 billion to a projected $76.9 billion by 2030, and there's a compelling reason why. We're seeing serious adoption challenges where 83% of organizations use machine learning, but over half of all projects get abandoned due to complexity. Let me show you exactly how major companies are succeeding with this approach. Airbnb achieved a 15% revenue boost using serverless machine learning for their recommendation system. Spotify improved user satisfaction by 30% with serverless content discovery models. And Uber reduced wait times by 25% by optimizing their driver allocation using serverless prediction systems. We're exploring the latest 2025 technology advances that are making this possible. Amazon Web Services Lambda now offers Snapstart technology with pre-initialized snapshots that reduce startup delays by up to 90%, plus support for advanced ARM64 architecture using Graviton2 processors for better performance. Microsoft Azure provides secure virtual network deployments with native integration for serverless functions, ensuring secure and isolated machine learning environments. And Google Cloud Run now supports GPU acceleration for machine learning workloads with pay-per-millisecond billing for optimal cost management. Amazon Lambda continues evolving as a cornerstone for serverless machine learning, offering robust capabilities optimized for performance, cost, and developer productivity. Snapstart technology achieves near-zero startup delays for Python-based machine learning functions, reducing response time by up to 95% with pre-initialized environments. The integrated development environment lets you seamlessly deploy and test models directly from your browser with real-time feedback and debugging capabilities. Graviton2 processors allow you to leverage ARM-based processing for up to 34% better price performance on machine learning workloads, optimizing your compute expenses. The new 2025 pricing structure benefits from an expanded free tier, now including 1 million requests free per month. significantly lowering barriers to entry. Let me walk you through the optimized system architecture. The foundation starts with proper imports and function setup, including essential libraries for JSON processing, file operations, timing, cloud storage, numerical computing, and logging capabilities. We configure comprehensive logging with appropriate levels and create dedicated logger instances. The system initializes cloud storage clients with transfer acceleration for faster performance using optimized configuration settings. A global cache system stores models efficiently, and the main handler function serves as the primary entry point for machine learning prediction services. We implement precise timing measurements and structured request processing, parsing incoming data with model identification and input validation. The system includes robust input validation that returns appropriate error responses for missing or invalid data. The prediction processing and error handling implementation focuses on reliability and performance. The system loads or retrieves models from cache using efficient caching mechanisms. We log all prediction activities with detailed model identification for monitoring and debugging. Predictions are made using optimized numerical processing with proper array handling. Response formatting creates a structured output, including prediction results, model identification, and precise timing measurements. Comprehensive metrics logging tracks performance with millisecond precision for monitoring. The system returns properly formatted success responses with appropriate status codes and JSON formatting. Exception handling includes detailed error logging for debugging purposes while maintaining security by not exposing sensitive information. Error responses use appropriate HTTP status codes with clear error messaging. Model loading optimization employs 2025 performance techniques for maximum efficiency. The system utilizes cloud storage transfer acceleration for faster downloads, implements persistent caching in temporary directories, uses concurrent processing with thread pool executors for parallel operations, and employs encryption for secure model storage. The streamlined model delivery process includes efficient model caching, optimized temporary storage, transfer acceleration from cloud buckets, and secure storage practices. The model retrieval function first checks cache availability, then downloads from cloud storage when needed. It sets up proper storage paths and checks for existing cached models. When downloading is required, the system logs the process and uses concurrent execution with thread pool management for optimal performance. Model loading uses industry standard formats with proper caching for future use. The serverless framework configuration optimized for 2025 includes comprehensive service definition with appropriate naming conventions. The provider configuration specifies cloud platform, runtime environment, advanced ARM64 architecture for Graviton 2 processors, appropriate memory allocation, reasonable timeout settings, HTTP API configuration with cross-origin resource sharing enabled, and provisioned concurrency to maintain warm instances. Environment variables include model storage location and logging levels. Security configuration implements proper access controls with specific permissions for cloud storage access and encryption key access for secure operations. Function definitions include proper handler specification and HTTP API event configuration with appropriate paths and methods. Key benefits include Graviton 2 processors providing 34% better price performance ratios, provisioned concurrency eliminating startup delays for critical workloads, and HTTP API gateway offering 60% lower latency than traditional REST APIs. Here are the actual numbers from the latest 2025 multi-cloud cost analysis. For 50,000 requests per month, traditional cloud computing costs £63.40 total. Amazon Lambda costs £41.69, representing 34% savings. Google Cloud Functions cost £62.52 with 1% savings. Microsoft Azure Functions cost £40.01 with 37% savings. The key insight is that serverless platforms excel with variable workloads and intermittent traffic patterns typical in machine learning scenarios. The real-world scenario becomes even more compelling. Most machine learning models experience sporadic traffic patterns rather than consistent usage. With traditional servers, you're paying for idle time when the system isn't being used. Serverless platforms only charge for actual usage, resulting in 80 to 87% cost reductions for typical machine learning workloads. For a more realistic scenario of 10,000 requests monthly, traditional cloud computing still costs £63.40 with the same fixed expenses. Amazon Lambda costs just £8.34, representing an 87% reduction. Microsoft Azure Functions costs £8.01, also representing 87% reduction. Google Cloud Functions costs £12.50, representing an 80% reduction. Let me share compelling production case studies from major companies. Capital One achieved remarkable results with their fraud detection system migration. They accomplished a 92% cost reduction for their low traffic fraud detection models, reduced deployment time to just 15 seconds, down from 45 minutes previously, and achieved zero infrastructure management overhead for their machine learning engineering team. Netflix demonstrates the scalability potential with a 20% engagement increase through real-time testing capabilities, automatic scaling from 1,000 to 1 million requests seamlessly, and 40 to 60% additional savings using their advanced optimization framework. Here's what the industry doesn't often discuss. The 2025 Orca Security Report revealed critical vulnerabilities in current deployments. 62% of deployed machine learning models have at least one security vulnerability. 98% of managed notebook environments retain dangerous administrative access. Most models lack proper input and output tracking for audit trails and compliance. The security requirements include encryption for model storage, role-based access control implementation, comprehensive monitoring and logging systems, input validation and data sanitization, and regular security scanning with timely updates. Secure model loading with encryption involves implementing proper security measures throughout the model lifecycle. The system imports encryption capabilities from security frameworks and initializes encryption key providers with appropriate credentials. The secure model retrieval function first checks cache availability for performance, then downloads encrypted models from secure cloud storage with proper path management. The system downloads encrypted model files and performs decryption using managed encryption keys. Model loading processes decrypted data using industry standard formats while maintaining security. The system caches models securely for optimal future performance while maintaining encryption standards. Microsoft Azure AI Foundry, introduced in 2025, provides enterprise-grade capabilities for machine learning deployment. Role-based access control offers fine-grained permissions for model access, training, and deployment based on organizational roles and responsibilities. Model governance policies provide automated enforcement of approval workflows, version control, and compliance requirements for enterprise environments. Secure virtual network access allows deploying models within private networks for secure connectivity with enterprise systems. The implementation includes managed identity authentication for secure access, private endpoint connections for enhanced security, secure prediction processing with enterprise-grade reliability, and proper response formatting with appropriate security headers. Cold start optimization strategies employ three key approaches for optimal performance. Amazon SnapStart pre-initializes execution environments and caches snapshots for instant resumption, reducing startup delays by up to 90%. Provisioned concurrency maintains 2 to 5 warm instances for approximately £8.40 per month for 2 instances, guaranteeing consistent performance for critical applications. Container image support packages models as container images for faster loading and better dependency management across different environments. The performance comparison shows traditional startup delays of 2 to 10 seconds, while optimized systems achieve 200 to 500 milliseconds, representing a 90% improvement in responsiveness. Monitoring and observability best practices ensure optimal system performance and reliability. Implementation includes comprehensive input and output tracking for full audit capabilities, integration with cloud monitoring services like Amazon X-Ray or Azure Application Insights, setup of reserved capacity for scaling beyond baseline requirements, and configuration of real-time alerts for performance issues and system anomalies. The monitoring implementation adds comprehensive tracking and metrics collection to system functions. The system patches supported libraries for complete observability and implements custom metric collection with precise timing measurements. Request identification enables detailed tracing, while input data recording provides comprehensive audit trails. Performance metrics collection includes processing time measurement and cloud metrics integration with proper namespace organization and metric definitions for operational dashboards. Let's summarize the transformative benefits of this approach. Serverless machine learning deployment in 2025 offers up to 92% cost reduction for real-world inference traffic patterns. It eliminates 95% of infrastructure management tasks, freeing teams to focus on actual machine learning work. It provides automatic scaling from 1 to millions of requests without any manual configuration or capacity planning. The concrete numbers for 10,000 requests per month show Amazon Lambda at £8.34 versus £63.40 for traditional servers, Microsoft Azure Functions at £8.01, and Google Cloud Functions at £12.50. The 2025 technological advances include Snap Start technology eliminating startup delays, Azure AI Foundry providing enterprise security capabilities, Google Cloud Run supporting GPU workloads for intensive processing, and the overall market growing to $76.9 billion by 2030. When 83% of organizations use machine learning, but 53% of projects fail due to complexity, serverless approaches remove those barriers completely. In the machine learning operations landscape of 2025, if you're not adopting serverless approaches, you're falling behind the competition. Here are your key takeaways. Serverless deployment reduces costs by up to 92% compared to traditional approaches. It eliminates infrastructure management overhead completely, allowing teams to focus on core machine learning work. It provides automatic scaling for machine learning workloads without any manual configuration. And it dramatically speeds up development and deployment cycles. Your next steps are straightforward. First, audit your current machine learning deployment costs to understand potential savings. Second, try the example approaches in your own environment with non-critical projects. Third, start with a non-critical model for initial testing and validation. Fourth, implement security best practices from day one to ensure proper governance. And fifth, use comprehensive monitoring to track both performance and costs continuously. Drop a comment for a custom cost analysis based on your specific workloads and requirement, and if this analysis of real costs and latest 2025 capabilities just saved you months of expensive infrastructure bills. Remember, in machine learning operations for 2025, if you're not going serverless, you're falling behind the industry leaders. I'm publishing cutting-edge machine learning, AI, and data engineering content weekly that keeps you ahead of industry trends. Thanks for watching, and please subscribe, like, and hit the notification bell. Connect with me or continue this discussion on LinkedIn. Link in description below. Read the full article or visit my other posts and articles on linkedin.com/in/Enan.